In this second video, we're going to be having a look at constructors. Now, so far we've already looked at what the difference between a class and object is, and we've looked at the term instantiation. Instantiation, if you remember, is when we actually create an object. Now, when we create an object, we may have to do some initialization. That initialization could be as simple as setting a few variables, or it could be more complex, such as connecting to a database or a loading of a file. So, when we say an object is being instantiated, we mean that the object is being created using a special method called the constructor. So the constructor is always called when an object is instantiated. Now, if we don't supply a constructor, it just kind of runs a default one, which essentially doesn't do a huge amount, but it is always there. So constructors are defined by ourselves and can come with parameters, or it could be parameterless. If we do supply parameters, then we're going to give data to the object when we instantiate it. So in order to explore constructors, we're going to be using a more concrete example than we had before. We're going to look at how to create a stack using object-oriented programming. Now, in AS, you would have already looked at what a stack is, so I'm hoping that you all remember. If not, maybe have a recap over stacks before you continue with this video. So stacks are first in, first out data structures, and we're going to create them using OO coding. So to start off with, I've got my stack class. Now, this special method here is the constructor. Now, I'm going to explain this constructor in detail, but I just want to kind of identify what it looks like. I'm also going to have a second class called node, and node where I'm going to use to store a single item in the stack. So my stack is going to be made up. Now, we have two constructors defined here. The first constructor is for the class stack, and the second one is for the class node. Notice that both of them have this self parameter. Whenever you create a method in Python and that method is not static, you have to supply self. However, in the stack class, there's no other parameters because there's nothing else I need to pass through to a stack when it first creates, because the stack is going to start off as empty. And you can see inside the class, I'm setting up two attributes. The first attribute is the top parameter, which is pointing to none, to say there's nothing in it, and also setting the size to be 0. In the node, however, I'm passing through a single item, a single parameter called value, and that's going to be the value I'm going to be storing in the node. And at the moment, inside this method, all I'm doing is setting the value to be the value passed through. Notice the difference here. They've got self.value and value. What I'm doing here is saying, well, the attribute value inside this object is going to be set to the value I've passed through as a parameter. Okay. This might seem slightly confusing, and it might be easier to maybe give this a different name, but I've done it this way to show that actually we can use the same name like this, as long as I use this self.start. You'll probably see on the internet that that trick is used quite a lot, which is why I've kind of introduced it here. So before we move on, can you remember what operations a stack can perform? So there's two main methods we'll have in a stack. The first one is push, when I'm adding something to a stack. And remember, that always goes to the top of the stack. And in pop will turn to the top of the stack. Now, the top of the stack will always be the last item I've just put onto it or just pushed on. I'm going to add an additional one just for debugging purposes called display, which simply displays the entire contents of the stack. Okay, this is purely so we can actually see what the stack looks like when we're practicing our coding. So let's have a look at how this class might then develop. So I'm going to start off with the node class. So here I've still got my constructor, but I've actually added an additional parameter called previous. Now, what previous does is it points to the last item in the stack. So if I've got a couple of items like this, so I've got A and B and C, then the previous, let's say C is my top, but I'll tell you there, the C's previous will be B, and B's previous will be A, and A's previous will be none, because it's not pointing to anything. So really the previous is saying what was the last item on the stack. I then got another method called setPrevious, which allows me to say, okay, this was what the previous is going to be. If you come back to the push method, okay, to add to a stack, what I do is I first of all create a node. Now notice when I'm using the constructor here, I'm passing through the value that I'm pushing on. Okay, so node value is going to pass through to here and be set in the object. I'm then saying the new node.previous is the top. Okay, so what I'm saying is I'm adding top. So I'm going to explain that in a moment how that works. And then I set the top to be that new node I've just created. So this is how it kind of works. So let's say I've only got one thing in my stack, an A. Okay, A top is pointed to the A node, and it's got a previous pointer to nothing. Okay, so let's see how this is going to work out. So I start off with A in the stack, and again, the top is pointed to A, and A is pointed to nothing. The first thing I'll then do is create a new node B, and then I'll say the its previous will point to the top. Now top's pointed to A at the moment, which is why the previous here is pointing to A. I then set top to be this new node, which is here, and then I have finished. So you can see now I've got the beginnings of a stack because the top's pointing to the last one I've added, and then that's pointing to the one before. So if we just see how C gets added, same idea, we create the node C. C will then point to the top, which was B, and then top will point to C. So I end up with this kind of stack. So I'm always going to pull items from the top, and then I can use the previous to say, okay, top's going to be B if I remove one, and so on and so forth. If I ran this code to actually see what the stack would look like, if I visualized it, it would look a bit like this. So top is going to have a node, and that node is going to have a value, which is C, because that's the top of the stack at the moment, and its previous is going to be another node. That node has a value of B, and its previous is yet another node. That node has a value of A, but its previous is none because it's not pointing to anything. So we've got the kind of C pointing to B, pointing to A. And that's the basic idea of how object-oriented stacks work. As it turns out, this is very similar to how object-oriented trees work, how object-oriented queues work, lists, etc., etc. Okay, it's a very common technique. So just kind of start to finish things off, I've got a display function, and all this display function does is effectively traverse the stack. So it starts off at the top. While stack current is not a none, i.e. it's not got to the end of the stack, we print out the value and then set current to be the previous. Okay, it's not going to remove anything from the stack, it's just simply going to print it out. So that allows us to effectively display a stack and push stuff onto it. The next thing to do is really to code this. So have a go at coding a stack in object-oriented Python, and then have a go at actually writing your own pop method. Now, I've not said how to do pop method, but hopefully from first principles you can maybe work out how it would work. The two tasks on IOS codes are on the slide right now.